T-shirt size, right? When we talk about the T-shirt size, so T-shirt size is basically the small size, medium, and large, right? But in other contexts, when talking about the height of the people, right? Height of the people. So this is in a centimeter, right? And similarly, when talking about the weight, so this is in a kg, right? Kilogram basically. Let's see the theme always. That's not a random choice. It's because a different type of data needed different type of measurements. Okay, basically different type of data needed different type of measurement. That's our analysis. Today, let's break down the type of data basically. Okay, today we are understanding all type of data, how many type of data that we have. Okay. So when we talk about the data, so let's start with the data. So in commonly we are considering the two type of data. Okay, let's break down in this much for pieces and understanding what is all of this. Right, let's understand. That's the two type of data. Basically, one is the qualitative, and second one is the qualitative and uh, quantitative data. Right, that's the two type of data. Basically, qualitative. Understand all of these things. What is the qualitative and what is the quantitative. So we are first understand and going with the qualitative data. Okay, let's break down in another simple term. This is qualitative data. When we're talking about the qualitative data, so qualitative data it means this is there are in the term of categorical data, right? Categorical data, categorical data. And similarly, when we talk about the quantitative data it means it's a numerical data. This is simple term of data. Quality data and similarly qualitative data is another two types. There are one is discrete in quality data. There is a two types. Basically, is a nominal data. Okay, nominal data, and second one is the ordinal data. Ordinal data. When you learn about the machine learning and you train your model, so data basically with this variable or that's a feature, there are different types. It may be in the form of 3.5 something like that, or there may be basically male, female, uh, male, and another way of writing is that red, blue, black, right? And one more thing, when you divided that, so this is 2.5, 6.1. That's all type of category you will see when you train or when you see the data for training your model, right? So in a nominal data, there are in a nominal data and ordinal data, right? In a qualitative, nominal ordinal. Basically, when we talk about the nominal data, so it can be no rank, no, background is simple term. So this is a no rank, right? And no rank. Similarly, this is no rank between what? Understand with the example. That is male and female. Okay. There's a no. You can't define that. Basically, there's no rank in between. There's a male and female. Another example is the red, blue, green, right? There's a no rank between red, blue, green. What is you can't rank in between them. Another example is a blood group that's A positive, O positive, A negative. You can't give a rank of that particular data, right? That is that type of data, which is red, blue, black. Okay, that's type of nominal data. Then similarly, when talking about the ordinal data, so in ordinal data, they give a basically rank. Okay, they give a rank. They give a rank. What does it mean? In simple terms, uh, understandable example has a clear order, right? Basically, has a clear order, but gap between them are not measurable, right? That's clear, is clear orderable, but gap between them and these are measurable. These are measurable. That's called ordinal data. Okay. In ordinal data, when you talk about some examples of ordinal data, so t-shirt of size, right? T-shirt size. So t-shirt size, is a small in size, medium, large, large. That's a t-shirt size, right? Basically, when you want to give a rank, so one, two, three. Similarly, basically the movie rating also giving it ranking, right? Movies rating, they give also give a wrong rank. This is a one is a bit poor. When you rating the one, that's a poor rating. Uh, Similarly, when you were two, so this is a that's average, and when you were three, this is a good rating. Basically, an excellent rating, right? This all about the ordinal data. And basically this is useful for when you learning the data, right? Similarly, when you doing the feature engineering, so in a normal data feature, you when you're doing the feature engineering for very useful for feature engineering, when you do the feature engineering, so we in a normal data basically you use is a ordinal encoding, right? ordinal encoding Ordinal encoding, and similarly when came the ordinal data, so in that particular case you use the label label encoding, that you will do small task or nominal and ordinal data. And similarly when you came in the qualitative data, so qualitative data, it's mean that data basically, that type of data basically the include all numerical value numerical value. Numerical value, it's mean what? Measurable count. It will be 1 to infinite. That's you call the numerical data. I know infinite 1, 2, 3, as well as decimal points came here. There's all type of data are qualitative data. In a qualitative data, simply we are okay. Qualitative data. When you talk about the qualitative data, there are also two types. Is a One is a discrete data, and second one, when you go to the second one basically is a continuous data, continuous data. When you talk about discrete data, it's in what? Discrete data, it's in basically the countable numbers. Okay, countable. Sorry, mistake. That is mean countable number. Understand? We will give an example. Let's we have data, right? That's a point. Okay, and this is a 2, 1, 2, 3 enough, right? That's a basically this we are calling the discrete. It's we are counting, and I'm just giving you example of four numbers. But when the real world data, when it came to the real data, and that's the millions of rows, millions of rows. In that case, you get the simple count data one, two, like this, so one and three, right? This countable data basically. You simply count that and understanding the example, right? Is basically tossing a coin. It's the best example. Tossing a coin. Another example is the book sale. Book sale. Basically the number of students in the class, number of students in class, right? This is the example of a discrete data. Then similarly, when we talk about the continuous data, so continuous data is the measurable. It's also measurable, but it can be any range, any any range. It's not. It can be any value, right? Any value. Understand the example. Height of the person. Height of height of a person. When we talk about the height of the person, the height of a person, it means every person have different technology. Say when you the data of millions rows when they come, so you can't count them. Basically, it's a large amount of different you basically unique value, right? Temperature, temperature. This all the concept of about the continuous value. And one more thing, understanding the discrete variable, discrete data. So it is a basically a no decimal point, right? No, no decimal point. Write down that point. No decimal point. What it mean? No decimal point. It's mean what? Basically, no decimal point. It's mean when you learn the concept. Okay. No decimal point. But it's mean the number of account, number of bank account, number of bank account, uh, uh, number of children, number of children. That's all the concept of a discrete. And similarly, when we talk about the continuous value. So continuous value basically decimal point, right? Carry the decimal point. Decimal point it means temperature. It's in a decimal. Height. It's also decimal point. Basically weight. This all in a decimal. So I hope this you will understand. And for tip, always identify the data type before applying the statistical method, right? When you learn about the concept, when you train your machine learning or before the training, you need to feature engineering. So for feature engineering, you need to understand the data, which type of